Hey everyone, sorry to do this to you, but I'm going to add one more variation of our elimination reactions because this variation is going to help us to make synthesis problems in the future more interesting. So to relate this new reaction or new variation to what we've learned before, let's look at this top reaction. Treatment of a tertiary alkyl halide with a very strong base, right? Also a strong nucleophile, but we know that either a strong base or strong nucleophile here would favor either SN2 reactions or E2 reactions. But however, with a tertiary alkyl halide like this, SN2 is not going to take place, and so this reaction would proceed through an E2 elimination. When it does that, it would follow the Zaitsev rule, giving us the more highly substituted or more highly stable alkene product. So our product would be this one here. Now the variation takes place when we use a base that's also strong, but that's very bulky. Okay, so this is tert-butoxide, like this. And what happens when we use tert-butoxide is because it's very bulky, it has a harder time accessing the more highly substituted beta proton. And so what happens instead is it removes a proton from the more accessible position. Okay, so this proton over here, lose the bromide, and so it gives us, as a result, the less highly substituted alkene as the product. Okay, so this is, we could call an anti-Zaitsev elimination. All right, so let's do a little bit of a comparison. This table here, which I in fact took off of one of our old textbooks, looks at an elimination reaction varying the different bases. So notice that this reaction is also of a tertiary alkyl halide, and it has either two methyl groups or this isopropyl group. Now, if we start with ethoxide, which would be rather small, not as small as methoxide, what it does is it follows the Zaitsev rule. So it eliminates to the more highly substituted side. So it eliminates, let's see if I can, eliminates to the left, gives us this more highly substituted product, gives us some of the less substituted as well. So 79 to 21% ratio. So oftentimes in organic reactions, products are not exclusive, and so we have to talk about major, minor products, this kind of thing. Now, if we make a change from ethoxide up to tert-butoxide, which is the one I showed on the last slide, that ratio essentially reverses. All right, so now we get 73% of the less substituted alkene. Now, we could continue on and we add ethyl group instead of a methyl group here. Look at the ratio of the less substituted becomes bigger. And if we did this with a triethyl group on here, it goes all the way up to 92% of the less substituted alkene. All right, so for us, what I'd like you guys to know is that if we use a small base, and it could be either ethoxide or methoxide, you can pick one of those, whichever one, we're going to get more of the more substituted product. So this is the normal Zaitsev elimination. if we use a bulky base, and let's just use tert-butoxide as kind of our prototype bulky base, you don't have to worry about using any of these other ones, we are going to favor the less substituted or the anti-Zaitsev elimination. All right, like I said, this is going to allow us to do some more synthesis problems, some more interesting ones. There are some problems like this on the practice exam problems, and I'm going to prepare a video key for that as well.